What's up, 20-1? First lesson here in the trigonometry unit. This trig is quite a bit different from the trigonometry that you'd look at in Math 10C, and it does get, kind of exponentially harder as you progress through, 20-1 and then 30-2. So here is the first lesson on, we're going to do a quick trig review from grade 10. And then we're going to talk about standard position angles and reference angles. So the first thing you need to know from Math 10 is that mnemonic device SOHCAHTOA. And you can take those to create your three trigonometric formulas, where sine theta is equal to opposite over hypotenuse, right? That's why we say so. Ka, which is cos theta, equals adjacent over the hypotenuse, A over H, and TOA, which is for tan theta, equals opposite over adjacent, so O over A. And we can use these formulas when we have a 90-degree triangle, and we are either trying to solve for a side length or an angle, assuming that you're given, certain pieces of information, either two side lengths or an angle and a side length. So let's do a few quick review questions here. So it says determine the value of x for each of the following. So in these two questions, for example 1a, we're trying to find dimension x, which is a side length. So the first thing we do with all of these trig questions in 10C was we want to go label our triangle. And so we start off by labeling the hypotenuse. So the hypotenuse is the longest side of the triangle. However, the hypotenuse, sometimes the better way to look at it is it's the angle across from the 90-degree angle. So that's my hypotenuse. Then I want to label the opposite. Whatever angle you are given, or whatever angle you are looking for, the side across from that angle is the opposite. The remaining side is the adjacent. Or you can say it's the other angle that connects to this angle, the other side that connects to the angle that's attached to the hypotenuse. A little bit more complicated that way. Anyways, so what I'm trying to do here is I'm trying to solve for dimension x. So whenever I'm trying to solve here, I always say, okay, like what pieces of information do I have? I'm looking for the opposite, and I have the adjacent. So out of these three formulas, which one has both an O and an A in it? Well, not so, not ka, but TOA does. So that means I'm going to use TOA to help me solve. So I would say tan theta equals O over A. And I'll take the information from this triangle and substitute it into this formula. So tan of theta, the angle here is 27 degrees. So tan of 27 equals the opposite, which is x, we're trying to solve for, over the adjacent, which is 4.28. And to solve for x, you can kind of rearrange in whatever way you want. Maybe you want to times by 4.28 to either side. Maybe you want to set up a ratio and cross multiply and divide. Whatever you want to do, it doesn't really matter. But let's say we're just going to rearrange. So x is being divided by 4.28, which means I need to undo that by timesing by 4.28 to either side. And so when I type that in on my calculator, tan of 27 times 4.28, we should get x is equal to 2.2. If you are typing that in on your calculator, tan of 27 times 4.28, and you're not getting 2.2, there could be a few different errors you're making. The first thing you need to do is go and check that your calculator is in degree. Now, if I look at mine, it tells me right at the top that I'm in degree, but depending on the type of calculator you have, it might not do that. So you need to go hit the mode button next to second and go to mode and make sure down here that degree is highlighted in black, okay? If you're in radian, you're going to get a totally different answer, and you'll learn more about doing trigonometry in radian when you get into 30-1. Right now, we're looking at angles as if they are in degrees. So make sure the degree function is highlighted every time you go to do some trigonometry. The other thing you might be doing wrong here is when I do this, tan of 27, I need to make sure I close that bracket. If you don't close that bracket, it's taking 27 and timesing it by 4.28 and then taking the tan ratio of that. You need to put the angle by itself in brackets and then times that by 4.28. Too too many 8s there, which will give me that 2.2 if I round it accordingly. Okay. So next question, let's go ahead to example B. So B is, here is I label this as the hypotenuse. This is that given angle, so across from here would be the opposite, and the bottom side we would then label the adjacent. If I have to go solve for H, well, I have H, or I'm looking for H, and I have A. So what formula has an A and an H in it? Well, CA does. So I would use that ratio, or that formula, cos theta equals A over H, and take what I know from this triangle and substitute it into here. So cos of the angle, which is 32 degrees, is equal to the adjacent, which is 13.8 over the hypotenuse. Now, people always, I find, struggle more with solving the hypotenuse than they do for something on the numerator. There's two ways you can solve here, right? I can rearrange, or I can actually cross multiply and divide to solve. I'm not sure what way you've been taught in the past, but let's just say we want to rearrange. What I need to do to rearrange here is I need to get the H off of the bottom. So I would times it by H and times by H. So now I'm left with H times cos 32 equals 13.8. So what I need to do is divide by cos 32. And so I'll take that 13.8 and divide by cos of 32, and that will get rid of it. And when I type that in on my calculator, 13.8 times cos of 30, divided by cos of 32, it should give me 16.3. Okay. The other thing you can do to solve there, just to know, is when you have cos of 32 equals 13.8 over H, well, this is technically over 1. So I can cross multiply these two together and divide by cos 32, and I'll get the same answer regardless of how I choose to solve there. Okay, so hopefully you remember that. That's solving for a missing dimension. Example number 2 is now we're taking our trig ratios and trying to solve for an angle, solve for a missing angle. My initial process is going to be exactly the same. So here's that angle of interest, and we're going to go label my triangle. So across from 90 degrees is the hypotenuse. Opposite, or across from the angle of interest, or the angle I'm looking for, in this case, is going to be the opposite. And the side I haven't yet labeled is the adjacent. So what letters do I have? I have O and I have A. So I have O and A, which means I'm going to use TOA to help me solve this time. So tan theta equals O over A. So if I substitute into here, tan theta equals O, which is 5, over A, which is 3. Now I'm trying to solve for theta. And if you remember how to solve for theta, like technically what I'm doing here is I'm dividing by tan. It ends up on the denominator, and so I have to take the reciprocal. What happens is we say theta, right? Because if I go divide by 10, you end up with this. Tan -1 is equal to 5 over 3, okay? So you always use the reciprocal trig function when you are trying to solve for an angle. So when I'm typing this on my calculator, I would go second tan, and that gets me tan -1. That is the reciprocal of 5 over 3. I close my bracket, and that's going to give me my answer in degrees. So 59, that angle, theta, would be about 59 degrees. Okay. And maybe you want to pause the video, try B by yourself, see what you remember. What you want to do is label your triangle. So H, this is the angle of interest, so that's O and A. And what sides do I have numbers on, or what I have information on O and H? So I'm going to use so. So that's sine theta equals O over H. So sine theta is what I'm trying to solve for, equals O, which is 2.6, over H, which is 5.4. So theta, when I'm solving for that, is sine -1, because I'm essentially dividing by it, which then I have to take the reciprocal. So sine -1 of 2.6 divided by 5.4, theta is equal to 29 degrees. Okay, so you use your reciprocal trig angles when you are trying to solve for an angle. All right, all of that should be reviewed from Math 10. Let's go look at a little bit of information that you're going to need to be successful next year in 30-1. First thing here is talking about angles in standard position. So an angle is in standard position when its vertex is at the origin and its initial arm is on the positive x-axis. So essentially what it's saying is, if I take this angle, and I'm trying to say what's theta, I have to arrange it such that this arm is going to go on my x-axis, and what we call the terminal arm moves is the vertex right here is on the origin. And so, I could say then I'm looking at this angle. Okay? So that's an angle considered in standard position. Another one would be like if I have my initial arm right here, and let's say my vertex is on the origin and my terminal arm ends down here. So that angle there would be considered an angle in standard position. So you start here and you kind of move from there. Okay? Something that would not be in standard position is, if I just slap an angle over here and I say, what's theta? Well, that's not in standard position, and I can't use my axes to help me solve that angle, right? Same thing if I take this and I say, here's this terminal, my original arm, and, what's this angle? Well, the initial arm needs to be on this x-axis. So that would not be considered an angle in standard position. Standard position will always start at x, and the point of the angle will be on the vertex and move from there. So with that same kind of logic, if I had, a point here and here, that's not in standard position. If I have this as my initial arm, but I go this way, again, that's not in standard position because the vertex is not on the origin. Okay? Talking about standard position, now we have two different ways of measuring angles. So positive angles are measured counterclockwise. So for example, if let's take this, I say here's this angle, here's this terminal arm. What is this? Well, I would say that's probably 90 plus 45, so that's probably about 135 degrees. When I start here, and I go clockwise, I end up with a positive angle. If I want to approach this from the reverse direction, so I'm still starting in the same place, but now I'm going clockwise, that angle would be, the negative value of that. So that would be 180 plus 45, so that would be a negative 225 degree angle. So angles measured clockwise are negative. Counterclockwise from that starting position is positive. So let's say I had this angle here, and I said it ends right here. What would that be as a positive angle? Well, as a positive angle, that would be 330 degrees. As a negative angle, that would have to be the remaining amount for that to add to 360 degrees, which would be a negative 30 degrees, right? These, in terms of their absolute values, excuse me, should add up to be 360 degrees because that's around a full circle. All right, a few questions here. Just for an example, so it says sketch the following angles. So sketch 130 degrees. Well, I'm always going to start right here, so my angle would start right here. Positive means I have to go in this direction, and so this would be 0, this would be 90, this would be 180. So if I was to end, my terminal arm is probably going to be somewhere around there. And I would say that's approximately 130 degrees. Okay. Negative 90. Well, again, we're going to start in the same place. But now if it's negative, my angle is going to go clockwise. So that would be down here at negative 90 degrees. 490 degrees. Well, I would start here. And if I go around once, that's 360. Add another 90 to that, that's going to get me to 450. And so 490 is probably going to be right around there. So I'm actually going past my terminal arm, past that vertical axis, and continuing. Negative 300. So again, I'd start at my x-axis and negative. So this is 0. This would be negative 90. This would be negative 180. And this would be negative 270 if I'm going clockwise. So my terminal arm for 200 would probably be somewhere around there for negative 200 degrees. Okay. Okay, so reference angles. Reference angles are super important to understand in order to be successful for trig in Math 30-1 because we use these reference angles to help us solve using our trig ratios, which we'll learn next lesson. So reference angles is the angle between the terminal arm and the horizontal axes, or that x-axis, okay? Reference angles are always going to be between 0 and 90 degrees. So if I'm looking at this, where are the reference angles for each of these terminal arms? So it's between the horizontal and the terminal arm. So this right here would be my reference angle, okay? This right here would be my reference angle, and this right here would be my reference angle. And so I can figure out what each of these reference angles is based off of the position of that terminal arm. So to figure out this reference angle, theta here is my reference angle. I would just have to go 180 minus 155. So that theta there is about 25 degrees. Let's just call that theta 1 for. So theta 1 is equal to 25 degrees. So the reference angle between the x-axis and the terminal arm. Next one, we'll call this theta 2. So to solve, theta 2 is again my reference angle because it's between the terminal arm and the horizontal. Now it could be horizontal up or horizontal down. So that's my reference angle. To solve for that theta 2, well, this reference angle, this part is 180, and the reference angle is just the rest of it. So the reference angle, theta 2 here, would be 220 minus 180. So theta 2, my reference angle, is about 40 degrees. Next one, we can call that theta 3. Well, again, theta 3 is my reference angle. I'm just going to call that RA for now. And this one, actually, my x-axis is here, and here's my terminal arm. So theta 3 is just going to equal 60 degrees as my reference angle in quadrant 1. Okay, so reference angles are always between the horizontal and the terminal arm, and it could go up or down from there. Some other pieces of information that you have to kind of memorize, commit to memory, are a few different rules here. Are the quadrant rule, and so when we are numbering or kind of labeling quadrants, we label them, we start here, and we are going to number them counterclockwise, the same way that we are measuring positive standard angles. So this would be quadrant 1, quadrant 2, quadrant 3, right, as I come around, and quadrant 4. Again, that's just something you need to commit to memory. Start at the x-axis on the right and go around 1, 2, 3, 4 quadrants. The cast rule. We're going to come back to the cast rule as we look a little bit more at trig ratios, but just to introduce it for right now, the cast rule tells us in which quadrant a trig ratio will be positive. Tells us which quadrants a trig ratio will be positive in. Okay? So the cast rule looks like this, C-A-S-T. Not the same, like when I'm spelling the cast, so it's not starting in the same quadrant as when I number. It starts in the bottom right. What this means is that here, all trig ratios are positive in this quadrant. Okay? Down here, this would be the sine ratios are positive. T would be the tan ratios are positive. And here, the cos ratios are positive. Okay? Again, those are just two rules that you need to commit to memory. And we'll come back to the cast rule a little bit more when we look at the trig ratio unit or section. All right, so example number 4 says, determine the measure of 3 other angles in standard position, which is between 0 and 360 degrees, that have the same reference angle as 28 degrees. So, sketch my axes here. And it's saying, here is one reference angle of 28 degrees. There are 3 other angles measured in standard position that have the same reference angle. And so remember, the reference angle is between the horizontal and the terminal arm. So some other places I could put that and have the same reference angle would be right here, where this is 28 degrees. I could put it here and down, where this is 28 degrees. I could put it here and down, which is also 28 degrees. But what I want to know is, like, what is the measurement and the actual measurement of each of those terminal arms? So let's say we'll call this arm 1. So arm 1, the measure of arm 1 is going to be from here and all the way to there. So to figure that out, what that is with the reference angle of 28, I would just go 180 minus 28 degrees, which is going to give me 152 degrees. Okay, I can do the same thing. Let's call this arm 2. So arm 2 is I start here, and then I got to go all the way to that terminal arm. So arm 2 is just going to be 180 plus 28 to get to that terminal arm, which gives me 208 degrees. And the last one is this one in quadrant 4, is I'd have to start here and go all the way around to arm 3. Well, to get to arm 3 with the with the reference angle of 28, I would have to go 360 minus 28, which gives me 332 degrees. So there are actually 4 different angles with that same reference angle. 28, 152, 208, and 332. So example B, last one that I'm going to look at. Okay, it says create those 3 other angles that have the same reference angle as 225 degrees. Well, 225 degrees as an original angle is going to be this angle here. Okay, that's 225 degrees. What I need to take from there is the reference angle. So to figure this out, I'd have to go 180 minus 225 minus 180. So this is actually 45 degrees. So the reference angle is 45 degrees, which means if I put, arm 1 here, this would be 45 degrees. If I put that same reference angle and go up to 45 degrees, angle arm 2 would have an angle of 180 minus 45, which is 135 degrees. And the last arm would be right here, arm 3, which would be all the way around to here. So 360 minus 45, which is 315 degrees. And so each of these have that 45 degree reference angle. And so 45, 315, this is 225, and 315 all have the same reference angle. Okay. So that's all I'm going to look at for today. I would highly suggest going and doing some practice questions. The answers are posted online. And then if you have any questions, please message me. Thank you for listening.